Greetings to everyone. So last class we have discussed the introduction of corrosion and then we have discussed about dry theory of corrosion. Now we are going for the next theory, that is wet or electrochemical corrosion. So wet or electrochemical corrosion, as the name indicates, it takes place in wet or moist conditions. And electrochemical corrosion, so it is by the electrochemical process. So there is a conducting liquid in contact with the metal, or when two dissimilar metals or alloys are either immersed or dipped partially in a solution, this type of corrosion takes place. So it exists due to the separate anodic and cathodic areas or parts between which current flows through the conducting solution. So in the anodic area, oxidation reaction takes place, and so anodic metal is destroyed by dissolving or forming compounds such as oxide. So the reaction always occurring at the anode is oxidation and at the cathode is reduction. Right. So in the cathodic area, the reduction reaction takes place. So the metal which is acting as cathode is in its reduced form. So at a cathodic part, dissolved constituents in the conducting medium accept the electrons to form ions like OH minus, O2 minus, etc. So the metallic ions form anodic part and non-metallic ions form cathodic part. Diffuse towards each other through conducting medium and form corrosion products somewhere between anode and cathode. See, in chemical or dry corrosion, the metal oxide layer is formed on the surface of the metal. Whereas in wet or electrochemical corrosion, the corrosion product is formed in between the anode and the cathode. So this you have to remember. The metallic ions from anodic part and non-metallic ions from the cathodic part diffuse towards each other, forming somewhere between anode and cathode. So the electrons which are set free at the anodic part flow through the metal and are finally consumed in the cathodic region. So to sum up this electrochemical corrosion, we have formation of anodic and cathodic areas, then electrical contact between the cathodic and anodic parts, then electrolyte through which ions can diffuse or migrate, right? Corrosion of anode only, and the formation of corrosion product is between anode and cathode. Coming to the mechanism, so reaction at anode is always oxidation and at cathode is always reduction. And metal ions plus electron. So then it is of two types again, that is hydrogen evolution and oxygen absorption. So coming to the evolution of hydrogen. So the hydrogen evolution occurs at the cathode in concentrated acidic environment. Usually, ion surface is covered with oxide at least a few points or it may difference in hydrogen over potential from point to point. So due to this, some areas act as cathode with respect to other areas which behaves as anode of the cell. And galvanic corrosion takes place. So that is Fe given rise to Fe2 plus 2 electrons and 2H plus electrons gives H2 plus. So it is clear from the reaction that hydrogen evolution type of corrosion occurs by simple displacement of hydrogen ion from the acidic solution by metal ion. So you can generalize this statement by saying that hydrogen evolution takes place when in electrochemical series, wherever the metal ions are present above hydrogen, dissolve in acidic solution and evolve hydrogen. So this you can see. So here you have this diagrammatic representation where cathode is this and anode is more, cathode is less. Okay, this is the hydrogen and Fe2 plus ions are forming here and hydrogen gas is being evolved from the cathode. Next, coming to the absorption of oxygen. So oxygen absorption mechanism occurs in alkaline environment. So hydrogen evolution takes place in acidic environment, and oxygen absorption takes place in alkaline environment. So area which is not covered with oxide becomes anodic with respect to the areas covered with cathodic, which become cathodic, and corrosion occurs by the following reactions. So again, iron giving rise to iron 2 plus 2 electrons. These are taken up by the oxygen to form hydroxyl ions. So these Fe2 plus and OH minus react to form FeOH taken twice, then FeOH taken thrice. Then if it is oxygen absorption is more, then it forms rust. That is Fe2O3 3H2 is the chemical formula of rust. So both anodic FeCl2 and cathodic product are soluble in water and diffuse towards each other. So here you have this precipitate out as yellow rust. So rust formation takes place in the absorption of oxygen. Okay? And this is the anodic area where you have Fe2 plus ions, and cathodic area is more here, anodic area is less. Okay? And then we have these OH minus ions which are from the reactor form, ferrous hydroxide, ferric hydroxide, and later on rust formation takes place. Then, so wet corrosion or electrochemical corrosion has two parts in it, that is evolution of hydrogen and absorption of oxygen. Now we have factors influencing corrosion. What are the different factors that influence corrosion? So first, if you take the definition of corrosion itself, we have two main parts in it. That is, first one is metal should be present, and second thing is environment. So this factors influencing corrosion mainly depends upon nature of the metals and nature of the corroding atmosphere. So first coming to the nature of metals, in it we have position in galvanic series. So the metal higher in series is more active and suffers corrosion. Right? So what we say, the metal top in the series undergo more oxidation per electrochemical series. Similarly, galvanic series is given where we include all the metals, non-metals, alloys, etc. Okay? So this, if it undergoes more corrosion, oxidation, that means it is undergoing more corrosion. So the top in the series undergo more corrosion. Next, purity of metal. Impurity of metal causes heterogeneity, that is heterogeneous nature, and form minute electrochemical cells, and anodic part gets oxidized or corroded. The nature of surface fill. So for this, you are going to write about filling Bedford's rule. That is, if the specific volume ratio is less, then oxidation rate will be more. If it is more, then the oxidation rate will be less. Next, nature of the corrosion product. That is, in this you are going to write about the formation of different metal oxide layers, that is porous and volatile. These two undergo further corrosion. Right? So you can write the nature of corrosion product about these. The nature of corroding environment. So for this, we have temperature. That is, with increase of temperature, corrosion rate also increases. Then humidity, higher the humidity of the atmosphere, greater is the rate of oxidation, isn't it? Because moisture is present there, so more electrochemical reactions takes place, right? So which forms corrosion. Then effect of pH, that is acidic media also causes corrosion, and basic media also causes corrosion. So if it is more alkaline, then it will be more corroded, as we have seen in absorption of oxygen. So all these are the factors which influence corrosion. So today's lecture we have studied about wet corrosion or electrochemical corrosion, that is evolution of hydrogen and absorption of oxygen, and factors influencing corrosion, that is nature of the metal, in that position in galvanic series, purity of the metal, nature of surface film, nature of the corrosion product, And then nature of corroding environment, that is temperature, humidity, pH. So this is about the factors influencing corrosion. Next class we'll go for prevention of corrosion.